Okay, we're going to be looking at the Unit 4 practice quiz. There is a paper version of this, so if you do not have it for whatever reason, it is on It's Learning. If you'd like to hit pause and go print that off, you are welcome to do that. Okay, so this particular quiz covers scatter plots and lines of best fit. It also covers the introduction of parabolas and some vertical motion, kind of what's going on if the parabola represents vertical motion. So the practice quiz begins with writing the equation of a line of best fit. And so I'm going to zoom in here for question 1. And we're wanting to use the blue dots. Obviously, they are not blue on this black and white paper, but it is this point right here and this point right here. So remember that a line of best fit is y equals mx plus b. And we want two things, of course, always. We want m and we want b. And we have a couple of ways we can do this here, but I'll be honest with you and tell you that if you can count, you don't need to solve for stuff. So the method that I'm going to do on the practice quiz today is literally just counting, okay? So remember that we can find m by counting rise over run. And so if I count from point to point, from this point to this point, then I go down 1, 2, 3, right? So I fall 3. So my rise is actually -3. And my run is 1, 2, 3, 4, 5, 6, 7, 8. So my run is 8. Right? Making my slope -3/8. Now, if you want to write the ordered pairs and use y2 minus y1 over x2 minus x1 to find slope, you're going to find the exact same answer, okay? And I'm not going to spend the time to do that because I think you've seen that on a video like 12 times now. And then B, you know, we talk about B and we always say, okay, plug in mx and y and solve for b unless you can see it. And guys, I cannot stress this enough. If I want the y-intercept, then I'm going to ask myself, where does this line intersect the y-axis? Well, here's the y-axis right here. Okay, here's the y-axis. And the line that I want it to intersect is this line right here. So the thought is where does yellow meet pink? Where does yellow meet pink? Right here at 8. If you can see where the line intersects the y-axis, you have B. There is absolutely no reason for you to solve for it. So you have y equals -3/8x plus 8, right, where I plug m in and b in. When I've typed that in the calculator, in the first box, I'm going to type -3 slash, right, and then 8. And then in the second box for my y-intercept, I'll just type 8, right, because the first box is m and the first box is b. Second box is b, sorry. All right, so let's do the same thing for the second one. And again, I can see 2 points to plot from, and so I'm just going to count to find rise over run. So m is rise over run. I did it again. I'm going to keep writing RISU. And so I'm going to go from point to point here. I'm going to count 1, 2, 3, 4. So I went up 4. So that means my rise is +4. You can't see what I'm writing. There we go, +4. And then I'm going to run 1, 2, 3, 4, 5, 6, 7. So I'm going to run +7. And notice my slope is going to be positive because my line is increasing. Whereas on the first one, my line was decreasing, so my slope was negative. Okay? Then I'm going to try to find B. So again, I'm thinking, all right, I've got this y-axis, and I want to know, does the line intersect somewhere with the y-axis? I did a really good job there. So if you're having trouble, I'm just highlighting the two things that I want to know where they intersect. So then, of course, the question becomes, where does yellow meet pink? Right here at 2. Right? So that means if I want to do y equals mx plus b, mx plus b, my m gets plugged in as 4/7, and my b gets plugged in as 2. So I end up with y equals 4/7 x plus 2. Right? So the first box we would type in m, and the second box we would type in b. Okay, the next thing you're going to see on the quiz is a series of questions about, can you just name some things from the parabolas? So the first thing that I ask you to find is the vertex. The vertex is either the highest or the lowest point. I often say the vertex is the turning point. It's the point where the graph changes directions. So it's going down, 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 and then all of a sudden it turns and it's going up, 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 up. So that turning point is the vertex, which would be 0, -9 in this case. The axis of symmetry is going to be the line that cuts the parabola in half. And you're going to give the x value of where that happened. So the x value of that would be 0. And guys, the vertex x and the x from the axis of symmetry, they should be the same number every time. All right, next thing here is, where does the graph meet the the x-axis? So I'm going to color the x-axis purple here. So here's the x-axis. And so we want to know, where does this graph hit the x-axis? So where does parabola meet purple? So it looks like right here and right here. So we count lines, or spaces, not points. So that would be 1, 2, 3 would be the first one. And 1, 2, -3 would be the second one. They will not always be opposite, so don't let this fool you. You're going to see this in the next one. If the vertex is not on the y-axis and the parabola is off-center, they won't be the opposite numbers. Okay? All right. Next one says y-intercept. So this is one of those problems where the point happens a couple of different times, but here's the y-axis. Here's where the graph meets the y-axis. So the vertex and the y-intercept are actually the same point in this case. Next question says, what does this graph have? Does it have a maximum or does it have a minimum? Well, if I think about these arrows tell me that this parabola is going to be going up forever, meaning that it has no maximum, right? There's not a highest point on the graph, but there is a lowest point. There is a lowest point. The lowest point is -9. So we would say this graph does not have a maximum, but it does have a smallest number. And in this case, the smallest number is -9, although it didn't ask for that. The next question says, is it concave up or concave down? Easiest way to tell concave up is that the graph's pointing up, right? Concave up means it's making a smile, like it's uplifting, right? So it'll be concave up, again, because the arrows are pointing up. So that's all for that graph. So let's look at the second graph here. I'm going to move some things so that you guys can see this. All kinds of things in the way. So the second graph here, we've got an upside down parabola. So let's do the exact same thing here. The first thing I asked you for is the vertex. So the vertex is occurring at the turning point. So you can see it going up, 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 and then all of a sudden down, 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 down. So here's our vertex right here at the turning point. And so that's the point 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, comma 9. Okay. Axis of symmetry, again, I'm finding that line that cuts the parabola right in half. It's always going to go through the vertex, right, where all the points on the left are the same distance from the points on the right. And so my axis of symmetry is going to be x equals wherever it hits the x-axis, which in this case is 1, 2, 3. And remember, the vertex x and the axis of symmetry x will always be the same. The x-intercepts, so again, I'm going to just really quick color the x-axis purple so you can see where does graph meet purple, where does graph meet purple. And so we should notice this graph here and here meeting the x-axis. So that's actually at the point 0, 0. And this one's actually at the point 6, 0. One more after 5. I didn't even count. And a little tricky again, the y-intercept is 0, 0 because that's where the graph is meeting the y-axis is 0, 0. So 0, 0 in this case is an x and a y-intercept. Next question is, does it have a minimum or does it have a maximum? So if I think about minimum, this graph has arrows that point down. So it's going to go down forever, so it has no minimum. But it does have a maximum, right? It comes up, comes up, so it comes up, goes all the way to 9, and then turns around and comes back down. So it doesn't get any higher than 9, so we would say, okay, our maximum is 9, so it has a maximum. And again, this arrows pointing down tell me that it's concave down. Or if it has a frown, it's concave down. It rhymes. All right, moving on to the back. Says plot the given points, determine whether the scatter plot would best be modeled by linear, quadratic, or neither. Explain how you know. And so 0, 5 is my first point. 0, 1, 2, 3, 4, 5. Next point is 1, 1, 2. And then 2, comma 1. Guys, remember the first point is left or right, and the second point is up or down, okay? So don't let that get you off. So I did 2, 1, now I'm going to do 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's a point. And then 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. And then 5, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it kind of looks quadratic to me, not super strong quadratic, but you see how the data was coming down and then all of a sudden it was going up again. And that point is kind of throwing things off right there. But in my opinion, this looks quadratic because the data changes direction. Right, it has a turning point. So the next question says, if the first point were changed to 0, 0. So if I changed this first point right here to this point, okay? So if you can imagine, I'm just going to erase where I connected the dots here. If you can imagine this one gone, would that change your mind about the direction of the data? And yeah, I mean, you would really suspect that if that first point had not been 0, 5, that the data would be linear. Oops, let me see if I can be consistent here with what I'm writing with. All right. So number 4, you're matching your scatter plots to negative linear, positive linear, nonlinear, no correlation. So first one you can see starts high, goes low. So that's definitely negative linear. second one, you see how it curves, changes directions again. That's really not linear. And this isn't, now that I'm reading this, can't put that. So on this one, I would put not linear, right? Because it's got all the changing of the directions over and over. Second one, positive linear, because the data is getting bigger and it looks like it's a line. So that would be positive linear. And this one, it just looks like a scattered bunch of points, right? And so I would say no correlation on this one, scattered bunch of points. How do I connect the dots? I cannot. All right, I'm going to zoom out just a little bit. It says if you were to sketch the graph of a function that represents the height of a rock launched upwards from an initial height of 25 feet, reaches a maximum height of 100 feet in 3 seconds, find and explain the following. Okay, so let's see if I count by tens. That would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And I'm going to do half seconds, so that's going to be 1, 2, 3. That might even be too small still, but let's see, 1, 2, 3, 4, 5, 6, 7. Okay. And I'm going to use a pencil because I might mess this one up the first go around. I might need to resketch. So we have an initial height of 25 feet. So remember, initial height, it's going to happen right here. So that's where it starts. And then it reaches a maximum height of 100 feet in 3 seconds. So here's 3 seconds. We're going to go up to 100 feet. And it wants us to find and explain the following. So I'm just going to draw my line of symmetry and reflect this point over here. 1, 2, 3, 4, 5, 6 away. So I go 6 away on this side. And I'm just going to sketch my parabola. Oops, I might have done an ugly job. But something like this. Okay. So my vertex is going to be the point 3,100. And it's just saying the rock reaches its max height of 100 feet in 3 seconds. That's what the vertex tells us. The x-intercept, which looks like it's about 6.50, tells us the rock hits the ground in about 6.5 seconds. The rock hits the ground. Sorry, my handwriting is really bad today. In about 6.5 seconds. Your graph may be a little different than mine, and that's okay as long as it makes sense. And then the y-intercept in this case is 0.25, and it's initial height of 25 feet. Okay, last question. We have assume a parabola to the left represents the height of a basketball shot during a game, given in seconds. First question says, from what height was the basketball thrown? So this is estimation here, 0 to 5, 5 to 10, so somewhere between 5 and 10. I think like 8 or 9 is a reasonable answer. So I might, 6, 7, 8, I might say 9 feet, although that's kind of crazy. As a really tall human, about 9 feet. Next question says, what was the maximum height the ball reached? And so I'm looking at this right here, and I'm thinking, well, that probably looks like about 16 feet. Remember, the vertex is the maximum. Part C says, how long did it take the ball to reach that maximum height? So if I look here, I might say, I don't know, 1.25 seconds, 1.3 seconds, 1.2 seconds, you know. D says, assume the player missed completely. How long did it take the ball to hit the court? So here is where height is 0, right? Because it didn't go up or down at all. Height is 0, so just past 3. So I might say 3.1 seconds. So every time I'm thinking, what's that point? What's that point? And what does it represent? Huh, look at that. So if I'm looking at point 213.4, and I want to know in context of the problem, I realize this is a little tiny bit confusing because the basketball problem that we worked in class, I had a goal right there, right? But we don't know that there's a goal right there or a net or whatever. And so all we really know about the point 213.4, because we don't know if it's a special point or not, is that at 2 seconds, the ball was at a height of 13.4 feet. That's all we really know. Okay? All right, guys. I hope this helps you, and I hope everybody does amazingly well on the quiz tomorrow. I'll see you then.